Hello everyone, welcome back to our channel Adivigyan Engineering. Today we will learn volumes and surfaces of revolution. So let us see what is volumes and surfaces of revolution. Let us say we have a regular plane curve that looks something like this. Let us say this is a regular plane curve. This is AB. Okay, and G is a line. Let us say this is a line. This is our G line. G be a line lying on the plane of the curve. And let us say this is AC, this is BD, are perpendiculars dropped from A and B on the line G. Now, if we consider a region R enclosed by the curve AB, the line G and the lines AC and BD. Now, this region R is revolved. Let us say this is the region R, and this region is revolved about G. If we revolve this region about this line, okay, then we will get a solid. Okay, so let us first draw this. Okay, this is the solid we got, and this solid is called solid of revolution with G as the axis, and the volumes and surfaces of this solid is called volume of revolution and surface of revolution. In our syllabus, we are mainly concerned with the revolution of a continuous curve about x-axis or y-axis. So let us see one by one. So our first topic is volume of revolution. The axis of revolution being x-axis. Okay. See, if the region R enclosed by the curve of a continuous function y equals to f of x, x is from a to b, x is from a to b, the ordinates x equals to a, x equals to b, and the x-axis be the x-axis be rotated about the capital X-axis, that is our, let us say this is our x-axis, and we have to rotate about this axis. Okay, then the volume of revolution would be pi integration a to b y square dx, and y is fx, then we can say this is pi integration a to b, and this is f of x square dx. This is the thing you have to remember. We don't need to see the proofs, because if we know the formula, that will be enough. Now let us see volume of revolution, the axis of revolution being y-axis. Volume of revolution, the axis of revolution being y-axis. And here let us say our region is R, that is enclosed by the curve of a continuous function. Let us say this is x equals to pi of y, and here y is from C to D. Let us say the abscissa y equals to C, y equals to D, and the y-axis be rotated about this capital y-axis. Then the volume of revolution would be, this will be pi integration C to D x square dy. So this is pi integration C to D, and x is phi of y. So this will be phi of y square dy. Okay. So let us see some examples. Let us say R is the region enclosed by the hyperbola xy equals to 2. Y is 1 and y is 4. And y-axis, if R is revolved about y-axis, then what will be the volume of revolution of this? So then the volume of revolution so let us draw the graph first. This is rectangular hyperbola curve xy equals to c square. So let us say we have the graph in this format. And y is 1. Let's say this is y is 1. This is y is 4. And R is revolved around y-axis. So R is revolved around this axis. This region is revolved around y-axis. So if it revolves around y-axis, we just have come to know the formula, that is pi integration c to d x square dy. So it will be pi integration c to d, that means y equals to 1 to y equals to 4 x square dy, and we know what is x. X is 2 by y, that is x square will be 4 by y square. So this will be pi integration 1 to 4 by y square dy. Okay, this would be y to the power minus 2, and the formula is y to the power minus 2 plus 1 by minus 2 plus 1. So it would be 4 pi y to the power minus 1 by minus 1, 1 to 4. So if we take minus outside, then it will be 1 by 4 minus 1. So this is 3 by 4, and 4 and 4 will be cancelled out. This will be minus 3 by 4. So answer is 3 pi. Okay, this is the volume of revolution. That means if you revolve this region, you will get a volume. Okay, and that volume would be 3 pi. Now let us see our next formula, which is surface of revolution. The axis of revolution being x-axis. Okay, so what would be the surface? So let us draw the graph. Let us say we have a curve look like this. This is your y equals to f of x curve, and you have revolved this around x-axis. So it will look something like this. And let us say we want to find the surface. We want to find the surface. So this is your A point, this is your B point. So if the region R enclosed by the curve of a continuous function y equals to f of x, x is between A to B, the ordinates x equals to A, this is the ordinate x equals to A, this is the ordinate x equals to B, and the x-axis be rotated about x-axis. Okay, x-axis be rotated about x-axis. The surface of revolution of this would be 2 pi integration a to b y square root of 1 plus dy by dx whole square into dx. This is the formula you have to remember. So we don't have the proof in our syllabus, so we don't need that. Now let us talk about surface of revolution. The axis of revolution being y-axis. So if this is the case, let us say x equals to phi of y is the continuous curve, and y is between C to D. The abscissa y equals to C to y equals to D. The y-axis be rotated about y-axis. Then the surface of revolution would be 2 pi integration C to D x square root of 1 plus dx by dy whole square into dy, and this would be the surface of revolution, and here axis of revolution is y-axis. And let us say now we want to see the volume of surface of revolution if the curved revolve is given by its polar equation and the polar axis is the axis of revolution. So let us see what would be the case. Volume and surface of revolution if the curve revolved be given by its polar equation and the polar axis is axis of revolution. Okay, so let us see the graph. Here we have x-axis and you have a continuous curve. Just looks something like this. Now is your AB curve. This end makes theta 1 angle with x-axis and this end makes theta 2 angle from x-axis. Okay, this is a graph. So let AB is the curve where the angles of A and B are theta 1 and theta 2. This is vectorial angles. This theta 1 and theta 2 are the vectorial angles. Okay, so let us say vectorial angles of A and B are theta 1 and theta 2. If AB is revolved about the polar axis OX, then volume of revolution would be pi from theta 1 to theta 2 r square sine square theta d of r cos theta, and surface of revolution would be y integration theta 1 to theta 2 r sine theta square root of dr square plus r square d theta. Remember these two formula. It will be helpful. Now let us see some examples. So our question is, the circle x square plus y square equals to a square revolves about the x-axis show that the surface area and the volume of the sphere thus generated are respectively 4 pi a square and 4 by 3 pi a cube. Okay, and now we know this that this is a circle passing through origin. Okay, where radius is a, so this side would be minus a. This is our origin. So you know that volume of revolution is volume of revolution about x-axis, right? So volume of revolution about x-axis is our pi integration a to b y square dx. So pi integration a to b, so here from minus a to a, right? Minus a to a y square dx. Here the graph is x square plus y square equals to a square. So what would be y square? It would be a square minus x square. This is pi integration minus a to a square minus x square dx. Okay, so now we have to use the property. This is from minus a to a, so it will be twice 0 to a f of a minus x. So if we put here, it will be 2 pi integration 0 to a. This should be a square minus x square dx. So this is 2 pi, and this is a square dx, that is a square into x minus x square dx. So this would be x cube by 3 from 0 to a. So this would be 2 pi. If we put a, it would be a cube minus a cube by 3. If we put 0, both of them will be 0. So it would be a cube minus a cube by 3. And if you simplify, it will be 3a cube minus 2 minus a cube, that is 2a cube by 3. So this is 4 pi a cube by 3. And what would be the area of surface of revolution? Area of surface of revolution. This would be 2 pi integration minus a to a y square root of 1 plus dy by dx square into dx. Now see, here the graph is x square plus y square equals to a square. So this means y is square root of a square minus x square. And if you do the differentiation on both the sides, it will be 2x plus 2y, differentiation of y is dy by dx is equals to 0 because a square is a constant term. So we can say x plus y into dy by dx would be 0, and this is dy by dx is minus x by y. So our required area would be 2 pi integration minus a to a, y is square root of a square minus x square, and this is 1 plus dy by dx whole square. Dy by dx is minus x by y. Minus x by whole square is x square by y square. Okay. Now if you do the simplification, it will be 2 pi integration minus a to a square root of a square minus x square. This would be x square plus y square by y square. X square plus y square is a square. So it would be a by y square, square root of a square by y square, that is a by y. Right? This would be a by y. And what is y? Y is again this thing, a square minus x square dx. So it would be 2 pi, and this will cancel out, a dx. So 2 pi a, integration of dx is x, and if you put the interval, it will be a minus a minus a, that is 2a. So it would be 4 pi a square is the answer. Okay. Now let us see our next question, which is find the volume and the area of surface of revolution of the solid obtained by revolving the region enclosed by the curve y equals to root under x and the lines x equals to 1 and x equals to 4 about x-axis. So let us first draw the graph. So you have y equals to root x. The graph is look something like this, right? If you have doubts, put the values of x, that is 0, 4, 16. You will get the y value. That means you can take only positive value of x here because it is under square root. So you will get only positive value of y. Now here the lines x equals to 1. Let us say this is the line x equals to 1 and this is the line x equals to 4. This is the area. This is the region and you have to revolve around x-axis. Okay. So what would be volume of revolution? This would be pi integration 1 to 4 y square dx. Integration 1 to 4 y square, that is root x square. It would be x dx. And what is x dx? This will be x square by 2. So pi into x square by 2 from 1 to 4. If you put the value, it will be 16 by 2, that is 8 minus half. So 8 minus half, that is 16 minus 1 by 2, that is 15 by 2. So it would be 15 pi by 2. This answer. Now let us see what will be our area of surface of revolution. Which is 2 pi integration 1 to 4 y square root of 1 plus dy by dx whole square into dx. Now this is 2 pi integration 1 to 4 y is root x. So y is root x. To differentiate it, it will be dy by dx is n into x to the power n minus 1, that is half into x to the power half minus 1, that is minus half. So it would be 1 by root x. So this is 1 plus 1 by 2 root x square dx. So you can say this is, if we take LCM, it will be 2 root x plus 1 by, sorry, it would be 4 root x, 4x plus 1 by 4. If you take 4 common, it will be 1 by 2. So ultimately it would be pi. 1 by 2 and 2 will cancel out. Integration 1 to 4. And if you take the root x into square root, it will be root x square. Okay, it will be x, and here you have x. So ultimately you have 4x plus 1 dx. And this is pi, and this is ax plus b format. So integration would be as similar as we know x to the power n format. This will be 4x plus 1 to the power half plus 1 by half plus 1, and I have to divide by 4 because it is ax plus b format. The limit is from 1 to 4. So it will be pi by 4, and this is your, if you put the value 4 here, it would be 16 plus 1, that is 17 to the power 3 by 2. Okay, and if you put value 1, it would be 5 to the power 3 by 2. Into here you have 3 by 2, that is 2 by 3 here. Okay, so you can say this is our answer. Now let us see one question, that is, let's see our next question. Find the volume of the solid of revolution obtained by revolving the smaller portion of the two region obtained by intersecting x square plus y square equals to 25 by the line x equals to 4 about y axis. So let us see the solution. Let us see the graph first. So here it's a circle passing through origin where radius is 5. So this is 5, 0. Okay. Now we need about the line x equals to 4. Find the volume of the solid of revolution obtained by revolving the smaller portion of the two region obtained by intersecting x square plus y square is 25 by the line x equals to 4. So if you draw x equals to 4 line, so it is 5. Let us say this is x equals to 4 line. And if you put this value and you have to revolve the smaller portion about y-axis. Okay. Now if you put 4 here because this line in intersecting the circle. So if you put x equals to 4, it would be 16. Y square is 25 minus 16, that is 9. Y would be plus minus 3. So this would be your plus 3 and this would be your minus 3. Okay. So we are taking the positive sides only. So let V1 is the volume obtained by revolving the region enclosed by so from here we can say that x would be square root of 25 minus y square. 25 minus y square, y is 3 and minus 3. Okay. And we know the volume of revolution about y-axis is I integration y equals to minus 3 to 3. You have x square dy. So x is this. The square root of 25 minus y square square dy. If you calculate, this will be in the format a square minus x square format. So a square minus y square square root. This will be pi. Square root and square will cancel out. So it will be 25 minus y square dy. This is pi 25y minus y cube by 3 from minus 3 to 3. Now let us put the values. This will be pi, which is 3 into 25, that is 75, minus 25 cube by 3, and minus lower limit. This will be minus 75, and minus 3 cube would be, minus will come outside, so it will be plus 25 cube by 3. So this will be 75 plus 75. This is 150 pi, and this is your minus 25 cube by 3. This is minus 25 cube by 3, and this will be minus twice 25 cube by 3 pi. Okay. Now if you calculate the values, let me check here if I have done any mistake, because we are taking 3, so it would be 3 into 25, 75 minus 3 cube. Oh, I'm extremely sorry. This should be 3 cube by 3. Three into 25, 75, and this would be 3 cube by 3 minus, we put minus here, minus 75, and minus 3 cube would be plus, minus minus plus, would be 3 cube by 3. So should be twice 3 cube by 3. 1 3 will cancel out, will be square. So this is 9 into 2, 18. So this would be 132 pi. And let V2, let V2 be the volume obtained by revolving the region enclosed by the lines. This is your x equals to 4, y equals to 3, and y equals to minus 3. So by the lines x equals to 4, y equals to 3, and y equals to minus 3. And y-axis about y-axis. About y-axis. This would be integration pi integration minus 3 to 3 x square dy, where x is 4. So 4 square dy. So it will be y This 3 minus 1 minus 3, that is plus 6. This would be 16. Okay, so it would be 96 pi. So what would be our required volume? Because in our question it is given, find the volume of the solid of revolution obtained by revolving the smaller portion of the two region, obtained by intersecting this circle and by the line x equals to 4. So you can subtract volume 2 from volume 1, so we'll get the smaller portion. So required volume would be v1 minus v2, 132 pi minus 96 pi. So this would be 36 pi. Okay. Now let us see our next question, which is find the volume of the solid obtained by revolving the cycloid x equals to a into theta plus sine theta and y equals to a into 1 plus cos theta about its base. So base of the cycloid is x-axis. So let us say this is your cycloid. Okay, and the theta is varies from, so let us say this is a CB graph and here theta is 0, theta is pi, minus pi here. So in this arc theta varies from pi to minus pi. Varies from minus pi to pi. So our volume would be pi integration minus pi to pi y square dx, and this will be pi integration minus pi to pi y square, that means a square 1 plus cos theta square, and this is your y square, and for dx you need to differentiate it. So x is a theta plus sine theta and dx would be dx by d theta. So by differentiating both sides with respect to theta, it would be a differentiation of theta is 1, differentiation of sine theta is cos theta, and d theta. So you got a into 1 plus cos theta d theta. So this would be a square into a, that is a cube, So it would be pi a cube, and this is from minus a to a. So it would be twice 0 to a. This is your 1 plus cos theta square and into 1 plus cos theta. So it would be 1 plus cos theta cube. So 1 plus cos theta cube. You have to simplify this, because we know cos 2 theta is 2 cos square theta minus 1. So if we have 2 theta here, we have theta here. So cos theta would be 2 cos square theta by 2 minus 1. So this is twice. So if we have theta by 2 here, we will have theta here. So 1 plus cos theta would be 2 cos square theta by 2. So we have cube here. So 2 cube it is 8. And we have multiplied by 2 square. So let me write it here, otherwise it will be confusing. Here we have minus a to a. So then we can say this is twice 0 to a. The function, it is 1 plus cos theta cube d theta. And in place of 1 plus cos theta, we have to write this. So 2 cube would be 8. So it would be 16 pi a cube integration 0 to pi. This is cos square theta by 2. So we have cos square into 3, that is 6 theta by 2 to d theta. So this would be 16 pi a cube. Let us solve this integration separately. Integration 0 to pi cos to the power 6 theta by 2 d theta. Okay. So let us say this is 0 to pi into, we can write this as cos square theta by 2 whole cube d theta. So this is 0 to pi this would be, we have to use this formula, that is cos square theta by 2 would be half of 1 plus cos theta. So this would be half of 1 plus cos theta and whole cube d theta. So this is a plus b cube, and half cube will come outside, so it will be 1 by 8. Okay. Now this is 0 to pi a plus b cube, a cube plus 3 a square b. So 1 square is 1 b, that is cos theta, plus 3 a b square, so 3 cos square theta, plus b cube cos cube theta d theta. Now this is 1 by 8, 1 into d theta, integration would be theta, and for cos theta integration is sin theta. So it would be 3 sin theta from 0 to pi plus 1 by 8 times this 3 cos square theta. So cos square theta we can write from here. This would be 2 cos square theta by 2 minus 1. Sorry, we need cos square theta. So this would be from here. You can say for cos square theta would be 1 plus cos 2 theta by 2. So this is 1 by 8. You can say 3 by 8. And this is integration 0 to pi 1 plus cos 2 theta by 2 d theta plus we can say 1 by 8 times integration 0 to pi. From this we can say this is cos square theta into cos theta. So cos square theta we can write it as 1 minus sin square theta and cos theta outside into d theta. So this would be pi and sin n pi is 0, so it would be 0, and if we put 0 it will be 0. So ultimately we get pi by 8 plus this is 3 by 16 1 d theta, that is theta, cos theta integration is sin theta, but here we have a theta format, so divided by a from 0 to pi. And here we can say this is 1 by 8. Here we have to apply substitution method. So let us say du is cos theta. So du would be minus sin theta d theta. Sorry, we have to take sin theta here. So it would be cos theta d theta. So cos theta d theta is your du and sin theta is u. So this is 1 minus u square. Okay. Now we have to change the limit. If you put 0, theta will be 0. If you put theta 0, u will be 0. If you put pi, theta is pi, it will be 0. So from 0 to 0 you will get 0. Okay. And so we can say that this would be pi by 8 plus we put pi. If we put pi here, sin n pi will be 0 and sin 0 will be 0. And if we put pi here, this would be 3 pi by 16. So if you take the LCM, it will be 2 pi plus 3 pi, that is 5 pi by 16. So this is our 5 pi by 16, and from here we have to, let us say this is our I. We have to multiply it by 16 pi by a cube. Let us say this is our I and this is I1. So 16 pi a cube into I1. So our integration is 16 pi a cube into I1. So I1 is 5 pi by 16. So it is 16 pi into a cube into 5 pi by 16. So it will be 5 pi square a cube. This is the answer. So here integration takes a lot of time. So you have to be very careful about this. Now let us see our next question. Question is, the line segment x plus y equals to 1. Y is from 0 to 1 is revolved about y-axis to generate a cone. Find the lateral surface area of the cone. So let's see how to solve this question. So here this line, if we draw, this is y equals to minus mx plus c minus 1, that is 135 degree, and positive intersection. This is the straight line. And if you put y equals to 0, you will get x equals to 1. So this is 1 comma 0 point. If we put x0, this will be 1. So this is 0 comma 1 point. And this line is x plus y equals to 1 line. So we have to find the lateral surface area. So from this we can say that the triangle OAB is formed by the line x plus y equals to 1, and y is from 0 to 1, and the region is revolved around about y-axis. So if it is revolved around y-axis, our required surface area would be lateral surface area would be the surface of revolution about y-axis. Surface of revolution about y-axis. So you know the formula, 2 pi integration is from y is from 0 to 1, x square root of 1 plus dx by dy square into dy. So our line is x plus y equals to 1. So this is 2 pi integration 0 to 1. X is 1 minus y. So square root of 1 plus, we have to differentiate it. So if you differentiate it, it would be 1. We are taking differentiation with respect to y. So x is your, you can say x is 1 minus y. So dx by dy would be 0. and this would be 1. So minus 1. And minus 1 square is plus 1. Okay. Into dy. So this would be 2 pi, and here we have root 2 here. So into root 2, integration 0 to 1, 1 minus y dy. So 1 into dy will be y, and this is y square by 2 if you put 0 to 1 limit. So this is 2 root 2 pi. Integration is y minus y square by 2 from 0 to 1. If you put 1, it will be 1 minus 1 by 2, that is half. So half and 2 will cancel out. And if you put 0, it will be 0. So pi root 2 is the answer. Okay. Now let us see one more question, and we will end up our lecture here. Let us see our next question. This is find the surface of the solid formed by revolving the cardioid r equals to a into 1 plus cos theta about the initial line. So our graph is this. Something looks like this. These are our cardioid. Now see, a cardioid is a plane curve traced by a point on the perimeter of a circle that is rolling around a fixed circle of the same radius, and it can also be defined as a epicycloid having a single cusp. So I think we have come to know what is cardioid is. Now see, this cardioid is symmetric about the line OX, initial line. So the required area is obtained by revolving only the upper part, this part of the cardioid about initial line. So you have to rotate this upper part. Okay. Now in polar form, this is your theta equals to 0, and this is your theta equals to pi. This is the point P, r comma theta in polar form. This is your theta. So the required surface area would be is 2 pi integration from 0 to pi, and we know it is r in polar form, we know it is r sin theta, square root of dr square plus r d theta square. So from this, let us first differentiate. Dr by d theta would be 1 would be 0 and this would be minus sine theta. So minus a sine theta. So we can say this is 2 pi integration 0 to pi r sine theta, and this is dr square, and if we take d theta common from this, so it will be square root of r square, d theta square common, it will be r square plus dr by d theta square, and d theta square will come outside, it will be d theta. So our dr by d theta is minus a sine theta. 2 pi integration 0 to pi. This is so this is r. R is a into 1 plus cos theta. A into 1 plus cos theta into sin theta square root r square, that is a square 1 plus cos theta square, and dr by d theta is minus a sin theta. So it would be a square sin square theta d theta. So we solve this. This will be, we take a square common, this will be a into a square. So this is 2 pi a square from 0 to pi. 1 plus cos theta is, we can write it as, we know that 1 plus cos 2 theta is 2 cos square theta. So if we have cos theta here, we will have theta by 2. So it will be 2 cos square theta by 2. So 2 and 2 it will be 4 cos square theta by 2. In sin theta we can write it as 2 sin theta cos theta. 2 sin theta by 2 cos theta by 2. And from this we will get, this will be a plus b square, and here we have sin square theta. So it will be 1 plus cos square theta plus 2 cos theta plus sin square theta. And if you take sin square theta plus cos theta is 1, so it will be 2 plus 2 cos theta. And if you take 2 common, it will be, let me write it here, otherwise it will be confusing. It is 1 plus cos square theta plus 2 cos theta plus sin square theta into d theta. So we can say that sin square theta plus cos theta is 1. 1 plus 1 is 2. If we take 2 common from this, let me solve here. If you take 2 common, it will be 1 plus cos theta. And 1 plus cos theta is 2 cos square theta by 2. So we'll have 2 cos square, 2 and 2, 4. So it will be 2 outside. cos square theta by 2, so it will be cos theta by 2. So we will have another 2 cos theta by 2. So it will be 4 multiplied by 2, it will be 8 multiplied by 2. It will be 16 pi a square, integration 0 to pi. It will be 2 sine, this will be sine theta by 2 cos theta by 2. This is cos square theta by 2. And from this, we got cos theta by 2 into d theta. Okay. Now this is cos theta by 2, 4 to the power 4. So this is 16 pi a square, integration 0 to pi cos to the power 4 theta by 2 into sine theta by 2 d theta. So if you take cos theta by 2 as z, it will be minus sine theta by 2 and half will come outside, multiplied by half into d theta would be dz. So sine theta by 2 d theta would be minus 2 dz. So it would be minus 32 pi a square. You have to change the limit here. So if theta is 0, z will be 1. If theta is pi, cos 90 is 0. So it will be 1 to 0. So this will be dz and this is our z to the power 4. If we change the order of the integration, then 1 minus will come outside. So it will be 32 pi a square 0 to 1 z to the power 4 dz. So it will be 32 pi a square z to the power 5 by 5 0 to 1. So if you put 1, it will be 1 by 5. So 32 by 5 into pi a square. This is the answer. So I think now you understand how to solve this type of question, and this chapter is extremely important. So I think that's all for today. Thank you. Have a good day and take care of yourself.